Okay, so the first thing I want to talk about is test corrections. I'll put more details in Schoology later, but before you can do your test corrections, okay, and no matter what grades you made, you can do test corrections. You're going to have to do a couple of things. You're going to have to write out, okay, let me start, I'm sorry. I'm like obsessing over why this is in my face right now, so I can't think and deal with my mask at the same time. Anyway, right now you can go back into Delta Math and you can look at what questions you got right and which questions you got wrong and how to work them, that sort of thing. So I'm going to put a question in Schoology probably during fourth period. If not, it'll be right after school. Kind of like I've done the discussion questions, but it's just going to kind of be open-ended. And you could go ahead and do it and like type it up in Word, and then you can copy and paste if you want. But so you're going to go through, let's say you missed 3 questions. You missed number 6, number 10, and number 15. So you put 6, 10, and 15. And then you go back and you look at them, and then you tell me why you got it wrong. Was it because you multiplied wrong, because you didn't answer it in the right format? Or like, well, I want you to reflect on it, okay, because that's an important part of your learning. Do that. And then also, if there's any Delta Math assignments that you have not completed 100%, you have to go back and do that. You do those 2 things, and then I will let you go and do the test corrections, which will improve your grade. Okay, does that make sense to you? But if you don't reflect on your mistakes and you don't actually do it the first time, you're not going to do any better the second time. I mean, that's just the way that it is. So that's just part of the learning process. And I'll give more details in writing this afternoon with due dates and stuff. I just kind of want to give you a heads up on what it is. Also, if you feel like there's a question and you're not really sure why you got it wrong because you feel like that's not, like your answer was okay, put that too, because I'll tell you, there's 2 things that somebody has brought to my attention. One of them was the way that the question was asked. It was tiny little wording different than from what I've done, and we'll talk about that today. But that's why I say the devil's in the details. Like, you got to be able to, and it's, I mean, I didn't discuss it the other way, so I'm not saying it's your fault. I should have done it both ways. But those little tiny ways questions are asked, it depends on how you answer it. And then also another one, I didn't give you the whole explanation of stuff, and then Delta Math asked it differently, or wanted the kind of the calculus answer, not the pre-cal answer, so I'll talk about that today too. Okay, it's because it kind of comes up in what we're doing, and so I'll cover those 2. So maybe on those you're like, I feel like this is correct because blah, 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 and then you'll get full credit back for that one. Okay? All right, so let's look at the notes. Yes. Okay, so I realized last period, as I was doing number 5, that it's the same as number 4. I felt like I was having deja vu, and I was like, wait, okay, we don't need to do number 5. So we'll start with number 6, but before that, I want y'all to look at number 1 and tell me, what did I do wrong on number 1? Or did you catch it when you were watching the video? Maybe you didn't catch it. Something's wrong here. Yes. Okay, so here's my excuse. It's not really an excuse. I mean, we're all capable of brain farts, but I started this video over like literally 10 times. I have a student assistant 4th period that was listening to me and probably laughing at me, so you can even ask her. I tried doing it in Cami, but I realized as I was doing it in Cami, anytime I've made a Cami video, y'all can't see my cursor. I didn't know that. I can see it, and you can see my cursor when I do Active Inspire, but I've been pointing at stuff, and y'all probably don't even know what I was pointing at. So I was like, well, can't use Cami. So I changed to Active Inspire over there, which makes my handwriting way worse when I'm at my desk. I didn't realize how much it was better in Cami than it is here. So I was struggling with all that. I couldn't even draw straight lines, and so I was very distracted. But yes, I totally messed up on the X-Intercepts. And I didn't even catch it. See, I should have caught myself when I wrote these 2 the same. I mean, at least I should have like flipped them both or something. But this should be -60 and 80. So please fix it on yours. I do know the difference, but again, and I think I probably said this yesterday, but we're as human beings, way more likely to mess up on the easy stuff than the more difficult stuff, because you're paying more attention on the more difficult stuff. You know, the easy stuff, I was just flying through, and I was probably still thinking about how bad this looked in Active Inspire and who knows what, but just fix it. And anytime you make mistakes like this, it's not the end of the world. As long as you really know what you're supposed to do, it's fine, and we move on. If you really think that's supposed to be the right answer, that's when the concern comes in. Okay, so now let's go to number 6. Or before I do that, do you have any questions on any of the ones you watched? Or have any, the way that I was transforming them, is that the way you've been doing it, or have you been making a bunch of T tables in the past? or both? Both? Okay. So the problem with making t-charts and just substituting in numbers is, first of all, you're not truly understanding the transformations. And then secondly, the numbers don't always come out pretty, right? It's, you know, it could be some crazy decimal, and that won't really happen here. And then you understand the concept more. The other thing I should have asked, because somebody mentioned something at the end of the last period, does everybody have a stylus? Okay. Because I think I'm going to have some that you can borrow, and we'll put in the dirty box back there. If it's the, I mean, try and have your own, but I don't want you sitting there with and you can't function. All right. All right. Let's look at number 6 then, because 5 is the same as 4. What is this parent function called? Somebody, or I'm going to cold call you. Absolute value. Thank you. So this is the absolute value. And so f of x equals the absolute value of x. And then my graph looks like this. All right. So then I'm going to look at transformations. I have 3, right? So, and to clarify also, because I don't know what class period, somebody asked something and I realized maybe in the wording you were thinking something other than what I intended. When I say if it happens before the function or before the absolute value or after it, I don't mean literally before, like on the left of it. I mean, is it inside or outside, basically? So this 1/4 is on the outside of the absolute value, so does it affect x or y? The 1/4. It affects what? Y. All right, so that means it's a vertical what? Compression. Very good. Vertical compression by 1/4. And then these two are translations. So the 2 means I go to the left 2. The 5 means that I go up 5. Okay? And when you're graphing, the translations have to come last. If you have multiple things before that, you can do those in any order. But the left, right, up, and down, those have to come last. Okay? And then we have to think about what our anchor points are. How many anchor points does an absolute value function have? It's either 3 or 5. Okay, you can do 5 if you want. There's nothing wrong with that. But if I can get those 3 on there, is that enough for me to get the rest of the shape? It is. So 3 is fine. It's either 3 or 5. 3 would be nice. Sometimes there has to be 5, right? Okay, so then we use our anchor points to actually do our transformations. So I'm going to start at this point. Do you have to memorize what they are? No, it's just have a general understanding of what's happening. If this is at -1, the absolute value of that is 1. So I'm starting at -1, 1. I have a vertical compression by 1/4. So I'm going to take my y value, multiply it by 1/4. I end up at 1/4. Then I go to the left 2 and up 1, 2, 3, 4, 5. And obviously you have to kind of estimate the 1/4, but the grid's kind of small, so you're good. And remember, in Cami, you can enlarge the graph so you can graph easier. I mean, you can, and I know it was hard for me to enlarge it and then also see the function, but you can see it up here or scroll. Okay, so then I'm going to do 0, 0. I multiply by 1/4, it's still 0. I go to the left 2 and up 1, 2, 3, 4, 5. Okay, so now yesterday I think I plotted like all of the anchor points. I don't need to actually count the third one. You can, and there's nothing wrong with it. But if you know you have the left side of this now, and it's symmetric, it's still going to be symmetric. So this has to be this point right here, up at 1/4. And I haven't played with Cami enough to know, like on this program I'm using, I can get a line tool that's probably in Cami, except I didn't actually use it there. It's probably in there and easy to figure out. I just haven't done it, so I'm going to cheat a little bit. Even when I cheat, I don't always get it right. Okay. All right, how are we doing? Everybody okay with all that? Any questions at all? If you have a question, you're going to have to stop me and ask me. Otherwise, I'm going to keep going. Okay. All right. So then I need to fill out all the information over here. What's the domain for this function? All real numbers. And that's the domain of the parent function, right? So we actually put negative infinity to infinity. And so even when I stretch it and squish it and reflect it and move it, my domain doesn't change. Did my range change from the parent function? Yeah, it did, right? So instead of going from 0 to infinity, I go from what? 5, because that was my vertical translation. So I'm going from 5 to infinity. Do I include the infinity? You never include infinity. Do I include the 5? Yes, because I can have a y value of 5. Good. Okay, X-intercepts. Am I going to have any X-intercepts? No. Okay, it's not going to cross the x-axis, so this is none. Am I going to have a y-intercept? Yeah, it's right here, but I don't get to guess off the graph. That's not a point I actually plotted, so I have to solve it. So to find my y-intercept, I'm going to do f of 0. That equals 1/4 times the absolute value of 0 plus 2 plus 5. Now remember on this stuff, I don't want you using calculators for anything. We have to learn a little bit of number sense and how to think through numbers quickly. This is going to be 1/4 times 2. So if you're going to take a fourth of something, you cut it in half and cut it in half again. So you got 2, you cut it in half, you cut it in half again, what do you get? Okay, 0.5 or 1/2. We really don't like decimals. Like, really, really don't like decimals. So we're going to go with 1/2, and it'll be 5.5. If I had ended up with 11 halves, I would have left it at that. The only reason we get to use a mixed number here is because that's kind of how it came together. It's not like I turned it into one. You don't ever want to turn it into a mixed number. You leave it improper. So my y value is 5.5, so this is 0, 5.5. Now, critical points. Here's why some of you may have gotten something wrong in Delta Math. And again, I'm going to go back and give you credit for that. And again, I should have kind of talked about it both ways. I'm asking you for critical points, which are ordered pairs. Okay, which means that those could be the absolute or relative max or mins or the point of inflection. If I ask you for a maximum value, that's just the y value. If I ask you for the maximum point, then that's an ordered pair. Does that make sense? So it asked you for the value, but some people put ordered pairs, and I understand why, because that's the only way we talked about it, so you were trying to answer it the right way. So I just kind of want to clarify that. And it's a little nitpicky the way that's asked, but you got to answer it right. But I'm going to give you credit for those. So do I have any critical points on this graph? Yes. Do I have any points of inflection? No. Do I have any maximums? No. I have a minimum, what kind? Absolute. So I have an absolute minimum, and since I asked for the points, that's at -2, 5. Okay? So now I'm going to add a little something else to this, because this is another reason some of the answers might have been a little bit off from what you had. In pre-cal, or up through pre-cal, we're usually looking at the entire function, or the entire graph. And we talk about, we do talk about some restricted domains, but overall we're looking at the entire graph. In calculus, you do look at the entire graph, but you also look a lot at little restricted domains. And so, and maybe that's all you know about the function, like you don't even know what the whole thing looks like, and it definitely isn't this simple. So let's say that we had just this restricted domain, okay? And that's all we got of the function. Like, that's it. We don't have a clue what's going on either side of my dotted lines. In that case, the best we could say about this is that it's a relative minimum because it's the minimum relative to the points right around it in that domain, okay? So basically, anytime you have an absolute minimum or maximum, it's also a relative minimum and maximum. It's both. It just has two categories. It kind of depends on what you use it as, depends on what you're doing at that point. And algebraically, we can't actually find those points anyway just yet because that's calculus material. So we look at them graphically and talk about it like that, but then you can actually solve for them when you get later. Okay, does that help a little bit? I'm kind of tweaking that that answer there. Okay, am I increasing anywhere? Yes? Where do I start increasing? -2. Good, because these are always intervals of x. So -2, I keep increasing into infinity. I never include the infinity. On increasing and decreasing at -2, are you increasing or decreasing? We could argue it either way. We could argue whether or not you're supposed to actually include that, but we're going to lean to the side of we're not going to include it. And then it's decreasing from -infinity to -2. All right, and then in behavior, as x approaches infinity, f of x approaches what? Infinity, good. And as x approaches -infinity, f of x approaches infinity, good. Any questions at all? If you have anything or I need to clarify anything, please, please say something to me. Okay, good deal. Okay, so we're going to do 7 partly together, and then I'm going to let you do 8. So why don't you go ahead and get the parent function and the transformation stuff written out on your own. I'm going to write it out as you're doing that, so just don't look up here until you're done. That way you don't have to wait on me to write it out after you're done. And when you're done, see if we agree. If we don't, or you have questions, let me know. Okay, then I want you to put your anchor points on your little picture. And it's just kind of an estimation of where they are. We're not actually graphing it. And I don't mean over here, I mean on here. Like put your anchor points on there. And how many anchor points are we going to have? What do you think? It's 3 or 5? 5, good. So if you get 3 on there, so the first 3, pretty simple, right? But if those are the only 3 that I have, I could make that into a line, I could make that into a cubic, I could make it into a cube root, like, I don't know. I need more to define my function, so I have to have 2 more. And again, as far as memorizing or knowing what they are, they should just make sense with the function. So I know if I take the cube root of 0, that's easy. If I take the cube root of -1, that's easy. If I take the cube root of -2, I don't know where the heck that is on the graph. So my next easy number to take the cube root of is 8, right? So that means this has to be at -8, -2. So you just kind of understand what's happening, then you know where they are. So let's start with -8, -2. So I'm starting here. I'm going to reflect in the y-axis, so I end up over here. I have a horizontal stretch by 3. So my 8 gets multiplied by 3. I'm way out there at 24. Not even worth me trying to count because that's just ridiculous. It's fine. I just know it's way out there. And then I have to go up 4. So that point doesn't really do me any good. I'm still going to have to think about it in the end, though. So then I go to -1, -1. I reflect in the y-axis, so I end up over here. I have a horizontal stretch by 3, so 1 times 3 is 3. So I don't move 3 to the right. I go to 3. And then I go up 1, 2, 3, 4. There's my point. And then, so I've taken care of this one and this one. So now I'm at 0, 0. I reflect in the y-axis. I go nowhere. 0 times 3 is 0. And then I go up 1, 2, 3, 4. So I took care of this one. Then I need to do this one, 1, 1. I'm going to reflect in the y-axis, have a horizontal stretch by 3, so I go to -3, then I go up 1, 2, 3, 4. And then if I do my 8 and reflect, I'm way out here at -24, so that's not going to do me any good either. But I need to think about what's happening with those points so that I can graph my picture accurately. Because you can't come in here and draw it in there like that, because that's wrong. You can't come from way up here and try and make a cube root, because that's wrong. I know that if I go one y value down, I'm supposed to be way out there at 24, right? So that means it's got to come in skinny like this, kind of like so. Now it's not really flat like mine kind of looks and yours might, and that's okay. You just need to know that it's not really flat, and mine definitely shouldn't go up right here. Let me fix that a little bit just so I'm not confusing. I mean, it's gonna, and there's not an asymptote either. Okay, we okay with all that? Any questions at this point? Okay. So, what's my domain here? What x values do I get? Are there any x values I can't have? No, then it's all real numbers, right? It's -infinity to infinity. Is my range also -infinity to infinity? Yes, because that's what it was on the original cube root, and that has this. None of these things have changed that. So -infinity to infinity. Okay, so then my x-intercepts. Am I going to have any x-intercepts? So here's how I know for sure. If my range is -infinity to infinity, eventually that's going to have to cross that x-axis, right? So I'm going to have an x-intercept. So I do have one. Do I know what it is? No. So I have to go and find it. So that means f of x is 0. That's equal to the cube root of -1/3 x plus 4. So then I would subtract 4 from both sides. -4 equals the cube root of -1/3 x. Okay. All right, so I'm trying to get x by itself. What's the opposite of taking the cube root? I cube it, right? So I'm going to cube both sides. -4 cubed. So let's I know you know it's -4 times -4 times -4. So in the end, is it going to be positive or negative? Negative, because it's a cube. So it's going to be negative. 4 times 4 is 16, right? So to make things a little easier, you're doing 16 times 4, which like you could do it and carry and whatever. But a couple of different ways to think about this, because again, and you know, our brains work differently than each other, and you kind of find what works for you. But if I want to multiply anything by 4, I can double it and double it again. So 2 times 16 is 32. I double that, I get 64. Okay. Another way to look at it is 4 times 10 is 40. 4 times 6 is 24. I add those two together, I get 64. Okay. It's not about doing it in your head. It's about streamlining the process so you don't have crazy scratch work everywhere. And you can still jot things down. Either way, it's -64. And then over here, I get -1/3 x. So then what do I do to get x by itself? Multiply by 3, specifically a -3, right? So it'll give me a positive answer. So let's talk about 64 times 3, because I definitely don't want you reaching for a calculator for that. I think it would be better for you not to, you know, do it like old school and carry and stuff like that. And different things make sense to different people. If I was going to do this, I would do 3 times 6, or 3 times 60, which is 180, and 3 times 4, which is 12, so that's very easily 192. And again, it's not about doing it in your head. I usually jot these things down or I'll forget what the first number was. So it's just a matter of kind of simplifying it. So I get 192. And then for me to correctly write my x-intercepts, my x value is 192, my y value is 0. So it's way out here on the graph, but I am going to cross the axis. Do I know what my y-intercept is? For sure. Yeah, I plotted the point, so I'm good. I'm at 0, 4. My critical points, do I have any maximums or minimums? No, but what do I have? What's this thing called? Point of inflection. Very good. And that is at 0, 4. Am I increasing anywhere? Nope. So there's none of these. I'm decreasing over the domain, so it's negative infinity to infinity. And then my end behavior, as x approaches infinity, what does f of x approach? What do you think? Right? As x gets bigger and bigger and bigger, y is getting smaller and smaller and smaller, right? So as x approaches infinity, y approaches negative infinity. Then the only time you go from right to left, as x approaches negative infinity, what is y approaching? Infinity. Good. What questions do you have? All right. Then I want you to do number 8 on your own. Okay, try and get like the whole thing done. If you have any questions or you're getting stuck on anything, let me know, because I can't really hover like I usually do. My eyes aren't good enough to see from too far away. So, and then we'll talk about it together. Okay, so I'll give you a couple of minutes to finish that, to do that. Okay, if you're on the video, you might want to pause it and continue to work because I'm about to work it, and then come back and look. Right, so see if you agree first. I know you're not 100% done with it, but do you agree with my first 3 points that I plotted? Okay, I can tell you how I got there, because then I'm going to talk to you about how I'm going to do the other ones. So you have to have 5 for a quadratic. So if I start off at -2, 4, I'm going to reflect in the x-axis. I'm going to multiply by 3. That gets me down to negative 12. Move to the right 4 and up 6. I'm here. Then I did that with negative 1, 1, and then I did it with 0, 0. Because I know right now that I have the left half of my parabola, I don't have to count the other 2 points. Like I can, but all of these that have symmetry, you can just use the symmetry. So I know that these 2 points are going to have to get me here and here, because it's not going to distort the picture. It's still going to have symmetry. And then I just do my best to get the curve in there. And try not to make it look too pointy. I mean, mine looks a little pointy, but it's not. It doesn't look like I'm trying to make a V, and that's important there. All right, so we only have a couple of minutes left, and I know you didn't have enough time to do all of this, but are the x-intercepts something you're going to have to calculate? Yes, and how many are you going to have? 2, right? And then y-intercepts, are you going to have a y-intercept? You are, because this is going to keep going, right? And then this point right here is a critical point. What would we call it? What kind of critical point is this? Absolute maximum and a relative maximum. Yes, good. All right, so if the bell rings on me, I will still finish this in the video. And so if you want to come back and make sure that your x-intercepts were right or whatever, we can do that. I'll go ahead and work on the x-intercepts. Maybe I can do it before the bell rings. The x-intercepts, I'm going to get 0 equals negative 3 times x minus 4 squared plus 6. Now I could square all that out, but I choose not to. I'd subtract 6 from both sides. So I get negative 6 equals negative 3 times x minus 4 squared. Then I would divide both sides by 3. So I'm going to get 2 equals x minus 4 squared. So then I'm going to take the square root of both sides. And when I do that, I get the square root of 2 equals x minus 4. Am I correct so far? What am I missing? The plus or minus. I introduced a square root, so I should have plus or minus right here. And then I add 4 to both sides, so I would have 4 plus or minus the square root of 2 equals x. And so although I have 2 x-intercepts, I can write it like that. That's fine. Then my 0, so f of 0 is equal to negative 3. Okay. Yes. Yeah, for sure without a calculator. We don't use a calculator in here until we absolutely have to, and for basic computations, that doesn't happen in pre-cal. Okay, so I'm going to finish this up. Let me figure out where I was. All right, so I've got 3 times, it's going to be 0 minus 4 squared plus 6. So it'll be negative 3. Negative 4 squared is 16 plus 6. So negative 3 times 16 is negative 48 plus 6. So that is going to give me a negative 42. So my y-intercept is 0, negative 42. My domain here is all real numbers, so it's negative infinity to infinity. The range goes from negative infinity, to 1, 2, 3, 4, 5, 6, to 6. This point right here, that is an absolute maximum and a relative maximum. And because it was asked as what is the point, that is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, 6. It's increasing from negative infinity to 4 and decreasing from 4 to infinity. On both end behaviors, we are approaching negative infinity. There you go.